This is vector A, and this is vector B. Vector A cross vector B is a vector, and the direction of this vector is perpendicular to both vector A and the vector B, or perpendicular to the plane of this paper formed by the vector A and the vector B. And the magnitude of the cross product is the magnitude of a vector A times magnitude of a vector B times sine theta. Theta is the angle between vector A and a vector B. And the component of vector B perpendicular to vector A, we call it vector B sub A. The magnitude of this vector B sub A is this. So vector A cross vector B has the same direction with the vector A cross vector B sub A. Because this the direction of this vector and this vector, they are both perpendicular to the plane of this paper, or formed by vector A and vector B, formed by vector A and vector B sub A. So this vector and this vector, they have the same direction, and the magnitude of this cross product is this, and the magnitude of this cross product is the magnitude of vector A times this times sine pi over 2, because these two vectors, the angle between them is 90 degrees. So they have the same, they have the vector, the angle between them is 90 degrees. So this is 1. And this is 1. So the length of this is this vector, the magnitude of a vector A times the length of a vector B sub A. And the vector B sub A, the length of a vector B sub A is this. Yeah. So this two have the same length and the same direction. So they are equal. These two vectors, they are equal. Accordingly, this is a vector A cross vector C is equal to vector A cross vector C sub A. Okay. Vector A cross vector B plus C plus vector C equals vector A cross vector B plus vector C sub A. Because this is a vector, so this cross product is the same with this cross product. Okay, now we are going to prove the distributive law of vector of cross product. This one. By using our notation B sub A, vector B sub A, and a vector C sub A. Okay, first let's look at the diagram. In order to prove this one. I'm going to rewrite the left part. Okay, the left part, vectors b plus vector c is equal this one. So this equals this one. Yeah. Okay, this is the proof of this b plus c sub a. Okay, so this b plus b cross vector b plus vector c sub a equals vector b sub a plus vector c sub a. Okay, this is the proof, geometrical proof. Vector a, vector b, vector c. This is a vector b plus c. So this is the parallelogram. This is a vector b, and we draw a line parallel to vector a. So this is a rectangular, and this is a triangle. So this vector, this is vector b sub a. This is the vector b sub a, and this is equal to this. This is a vector c sub a. So vector b sub a, vector c sub a equals vector b plus vector c sub a. So these two are equal. So vector a cross vector b plus c equals this, and equals this. Okay. So we have then we need to know what does this mean. Vector b a, vector c a, vector b a, vector c a, they are perpendicular to vector a. Vector a is a vector perpendicular to the plane formed by vector b a, vector b sub a, vector b c, vector c a, and toward us. Okay. So what we can see here, this is the vector b sub a plus vector c sub a, and this is from the and we know the vector a cross vector b sub a is a vector, and this vector is perpendicular to both vector a and the vector b sub a. Here we use right hand rule, and we move from the vector b sub a to the left by 90 degrees, and we will get vector a, the direction of this vector, and also we will get to the direction, get the line along the direction of vector a cross vector c sub a by rotating 90 degrees to the left from vector c sub a. Okay. And also we will get the vector, we will cross product, the vector of a cross product of a vector a cross this. And here, these two cross products, they are vectors, and we will form a parallelogram of these two vectors, and we will get a diagonal line here. So now we need to prove that this diagonal, we will get here the addition of these two vectors. And we need to prove the addition of these two vectors the same with this vector, this cross product. First, let's prove the direction, whether these two are in the same in the same direction. Okay. We know that this vector is 90 degrees to the left of this vector, and this is to the 90 degrees of this vector. So this angle formed by this vector and this vector is the same with this angle. Okay, as this is a parallelogram, so this is the same with this. So this is the same with this. Okay, and this vector is the same with this vector. So the ratio of this vector, the ratio of the magnitude of this vector over this is A, the magnitude of vector A, the length of A, and the ratio between the ratio of this vector over this vector is also A. So according to SAS, these two triangles are similar. Okay, as they are similar, so the length of this is the same with the ratio of this length over this length is the same with the ratio of this length over this length, or this the ratio of this length over this length. The ratio is A. So the length of this vector is BA. Okay, so the length of this okay, so we know, so we can prove the length of this vector, this cross product, and the length of the addition of these two vectors are the same. Okay, one by one. The length of this cross product is magnitude of a vector A times magnitude of this length of this vector. Okay, times the sine pi over 2, because this two vectors, A and A cross B sub A, this because these two this and this they are perpendicular to each other, so sine pi over 2 is 1. So the length of this is this, and the length of the addition of these two vectors is the ratio A times the length of this vector. So these two are equal. So they are equal. So and also they have the same direction. We have proved that these two are similar to each other. These two triangles are similar to each other, and so this angle has the same with this angle. They are equal, and also So here, this is this 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 and this. Okay, here, this angle is 90 degrees, and these two are equal. So this this angle is 90 degrees. Yeah. So this is the addition of these two vectors is in the same direction with this vector, because this is perpendicular to this. So these two vectors, they have the same length and the same direction. So we can say vector A cross vector B sub A plus vector CA is equal to vector A cross vector B sub A plus vector A cross vector C sub A. Yeah. These two are equal, and this one is equal this one, right? Is equal this one. Okay, this one is equal this one, and also we know that these two are equal. Vector A cross vector B. These two are equal, yeah. And these two are equal. So this, and also vector, we know that this one here is equal vector A cross vector B plus C. So this and this are equal. Yeah. So this is equal. These two are equal. So this is equal this. Now we have proved the distributive law of the cross product. Okay, now we are going to calculate calculate the cross product of any two vectors by using this coordinate. Look here. Here is the vector axis x, x, y, z with the unit vector I roof, j roof, and k roof. Using the right hand rule, we will get the cross products of these vectors. Vector I cross I roof cross I roof. The angle is 0, so this vector is 0, and I roof cross j roof, I roof cross j roof. Using right hand rule, direction is up, and it is the magnitude is 1, so it is k roof, and I roof cross k roof, I roof cross k roof, starting from I roof, moving to k roof, and the direction is opposite to j roof, so it is minus j, and so on. You will get these. Okay, so vector A is this, vector B is this. We can, using the distributive law and the results above, we get this, vector A cross vector B, and we will use this to time these three parts one by one, and this by to time these three, and this to time these three, we will get this. And then the result is this.